Hey everyone, today we're going to be talking about how to count your plaques and then how to use your plaque counts to calculate the titer of the phage lysate that you have. We are assuming by this point that each of you have flooded a plate, at least, and so you have a tube containing phage buffer with virus particles in it. This is called your phage lysate because the host bacterial cells have been lysed to release the virus particles. The plate that you're going to count is called the countable plate, and you want that plate to have between 30 and 300 plaques on it. These are two different examples of plates that fall within that realm. This one obviously is going to be closer to 30, and this one's going to be closer to 300, but these either or both of these could be counted. But I'm going to show you guys counting on this one. The way that I normally count is I get one of these little Sharpies, and I dot the plaques as I count them. So this helps me to be sure that I have counted them and also protects me from counting them twice. 1, 2, 3, 4, 5, 6, 7, 8. Sometimes the Sharpie is not that close. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, 30. 31, 32, 33, 34, 35, 36, 37, 38, 39. So we're going to say that this plate has 39 plaques. Happily for us, this falls within our 30 to 300 countable plate requirement. So we're going to use this number for calculation here in a minute. If you have a plate like this that also falls within the countable plate parameters but has a lot of phages, a lot of plaques, what I would do with this plate is still use your little Sharpie, and I would mark off sections of the plate to count. Maybe that section, maybe that section, and so on. And then you can count within each section using the dot technique, and then add all of your section totals together, and it will really decrease both your error and the time that you spend recounting if you get lost on the plate. So that's the way that I recommend you to count the plate. Once you've counted your plate, you'll need to keep track of both the number of plaques that you counted and the dilution of your plate. So now I'm going to go over with you guys how to use these two numbers to calculate the titer or the calculation of your phage lysate. So we're going to report our titer as something called PFU, which stands for plaque forming units per milliliter. So the vast majority of the time, a single plaque is caused by infection from a single phage. But a few times this does not happen, and multiple phages might stick together. Well, if they're sticking together to create one plaque, then they're just sticking together, and they need to actually be counted as a single plaque forming unit. They're not going to come back apart. And so for that reason, we report plaque forming units per milliliter as a more accurate measure than phages per milliliter. Plus, we can actually see the plaques, and we can't see the phages. So plaque forming units per milliliter, the numbers that you're going to need for that are the number of plaques that you counted, the volume of lysate that you infected with. So this is typically going to be the 10 microliters. This is the amount of virus that you've mixed in with the SMEG. And the last number that you're going to need is your dilution. So if you think about it, you have your tube of lysate, you're actually diluting it in two different ways before it infects the SMEG. The first and most obvious way is the serial or stepwise dilutions that you guys do, -1, -2, -3, like that. But the other way that you dilute it is by infecting with less than 1 milliliter. So you guys do typically infect with 10 microliters, which is 1/100th of a milliliter. So 1 microliter of 1 times 10 to the 9th dilution is going to be 100 times, 1 milliliter of 1 times 10 to the 9th is going to be 100 times more phage than 10 microliters of 1 times 10 to the minus 9. And so it's important to account for both of these dilution parameters in our calculations. So for the plate that we just counted, we counted 39 plaques. We infected with the standard 10 microliters, but remember, it's going to have to be in milliliters, so that's 0.01 milliliters. And then the dilution of this plate was 1 times 10 to the minus 9. Okay, so the first thing that we're going to do is we're going to rewrite our volume down here so that it has an exponent. So this would be 1 times 10 to the minus 2 milliliters, because we have to move the decimal point 2 places to the right to put this 1 into the 1's place. So 1 times 10 to the minus 2, and then we still have our dilution here, which is 1 times 10 to the minus 9. So we now have multiplied together two numbers that are 10 to the power of something. And so we know that when we multiply numbers with exponents, we can add together the exponents. And so now we can write this as 39 plaques divided by 1 times 10 to the minus 11th mils, because minus 2 plus minus 9 is minus 11. Oh, you guys, I should have been writing this as plaque forming units. Okay, so 39 plaque forming units, not plaques, because we're not really accounting for the number of plaques in our tube, which is 0. We're accounting for the number of phage particles that will cause plaques. And so this is supposed to be plaque forming units and not plaques. And then we're going to multiply that by the inverse of this number. So when we take the inverse, the negative exponent becomes positive. So this is going to be 1 times 10 to the 11th. And the milliliters stays down here in the denominator. So then we have 39 times 10 to the 11th plaque forming units per mil. And then we can rewrite that as 3.9 times 10 to the 12th plaque forming units per mil. So this is the number that people care about when they ask you about your phage lysate titer. This is the number that you'll write in your notebook, and this is the number that you'll write on the tube of your lysate once you've done these different calculations.